So remember, you have to have, in order to have separation of variables, you have to have a multiplicative relationship with the x and the y. There has to be some sort of way we can divide the y. You can't add it, you can't subtract it, you can't, it has to be a division. It could be multiplied because that's technically dividing as well, right? So as long as it can be multiplied or divided, you're fine. So let's take a look. That's what this whole assignment's about. So is there a way we can separate the x and the y by multiplication or division? So here we could multiply the y. If we multiply the y to the other side, you would end up with y dy equals 2x plus 1 over 3 dx. And then you just integrate. So that was a successful version of separation of variables. So we're able to multiply the y over to the other side. What about this one? It doesn't look like it up front. But remember earlier we're talking about if you have two exponents being added, can't we separate this out? So this is currently dy dx. So I can rewrite this as e to the x times e to the y. Right? Because as long as we're multiplying these two together, we're adding the exponents. So this is definitely something we can do. And then now we have that multiplicative relationship where we can divide that e to the y to the other side. So that would become 1 over e to the y because we're dividing it. dy equals e to the x. And actually, I want to go ahead and solve this a little further just to show you. We'd have to bring that e to the y up to the top. Forgot my dx. And then when integrating, we'd use u substitution on that. And so after using u substitution, you get e to the negative y. And I know I'm taking this a little bit further. Divide the negative, and then natural log both sides. So I guess I probably shouldn't have taken it that far, because we're just looking, can we separate it? And the answer is yes, we can separate it. But that is this is a very common one that you might run into. What about here? Is there a way we could separate this? No, I would have to add this. There's no way I can separate the y and the x with multiplication or division. If I factor out the y from everything here, you'd be stuck with more y's. Check it out. If I factored it out, I'd have 10 over y minus 2 plus 9x over y, and that just doesn't help us at all. So this one's no. This one was yes. This one was yes. Let's take a look at this over here. So is there a way we can separate the y using division? And I think we saw this one earlier because there is a way, and it wasn't earlier in this video, but the last video, and we could factor out the y to have 2 minus x. And then from there, you divide the y over. And then integrate both sides. So this answer is yes. All right, on this one, there's no way we can separate these. X times y, it's not like when we had the plus. The plus, we can separate it as multiplying the two, with the base e, you're adding the exponents. Here it doesn't work that nicely. At 3e to the x, it'd be e to the x to the y. That's the only thing we could really do here, and it doesn't really help us at all. So this one's going to be a no. I might as well just leave that as reference. So it can't divide or multiply to get the y function by itself. All right. What about this one? Looks a little different. You know, it's not like we can factor y out, but check it out. You can still factor x out, and I think we'd be able to divide. And there you are. You can divide that over. It'll be 1 over y plus 5. It'll take a little u substitution there, but it'll work. And then you can integrate. And there you go. There's a bunch of different situations where yes and no. There's only really a couple no's in there, but this one's yes. Some of them take a little bit of that reshaping though. So this might be a difficult assignment, but very important. I wish I had this in college because, like I said, this is one of those areas that I messed up. I can't even write my S's anymore. Nope. They just look so horrible. There we go.